I will get so most of what I'm going to focus on today is a walkthrough of VC3D, and then while I'm doing that, I'm going to make sure that the tutorial that I wrote to use VC3D is actually decent. I went through it when I made it. Go ahead.
Sean, you're sounding like a little echo or something. Like it's not the right microphone or something. I don't know.
How about now?
Oh yeah, now it's different.
Great.
But a bit more quiet.
Let me turn it up 1 sec.
It's way better.
This is about as high as I can make it.
Yeah, I think the sound quality is better like this. I don't know. Does someone agree?
Yeah, if you get, I mean, hopefully. Okay.
Okay, no. Yeah.
Okay. Maybe, hold on, let's try this actually. Is this better now?
Yeah, it's perfect now.
Okay.
I think those are okay for me.
Great. Okay, so let's do this then. So yeah, as I was saying, I'm going to do the, I'm going to go through VC3D. We do have some changes to it. So the tutorial will need to be updated. So I will do that as I go through it. So we'll achieve two things here. People will learn how to use VC3D, and I'll make sure that I'm not guiding people to the wrong documentation. The primary change in this is going to be, there's an installation step here. I would very strongly recommend installing this with Docker and not following this part. So we will have to change this, but I won't change this entire thing just yet. I'll do that afterwards because it'll take a little while. But all you got to do is go to this site here. Let me post this in the chat if I can figure out how to get her pulled up right there. And then if you go to that repository and you click on packages, you'll see this command right here. Edge, in this case, means the latest branch. It's like our development branch. So right now we have two branches. Well, actually, we really only have one. We have dev next, but once our first round of improvements are finalized, we're going to create a latest branch, and then there will be two branches. So you'll have dev next, which is our development branch, and then our latest branch, which will be the most recent stable branch. For now, there's only one, so all you've got to do is copy this. The starting point would be, I guess, if you have Docker installed or not. I guess I started assuming that you did. So I don't know, Marcel, if you do have it installed or not, or anyone else who might be following.
Yeah, I just went through the old tutorial completely, and I got it to run.
Great.
So I'm set up, basically, except for the new Docker, I think.
Okay, yeah, and this will actually be pretty easy. So the only difference for you would be instead of, and you can use the one, if you install it that way, you can just keep using that one. You'll have the exact same thing. All this does is instead of having to download the repository or clone the repository or anything, you can literally just type this Docker pull and it will build everything for you. That's the primary difference, is you don't have to actually do anything, which is great.
So the other container I have is the same version then, or?
Yes.
I used the Noble 2020. I don't know, the version in the repository.
Yep.
Yeah.
Yeah. So this is the same. So all the difference here is doing is basically when we host a container, we're basically running all these files, and then you're copying down the image that's already ran all this stuff. So you end up in the same place either way.
Okay.
So what I'll do then is just pull it up. When I run my Docker container, I do a couple things which I've said in the guide as well. First, you've got to add your X host because you have to forward your X server from your computer to Docker or through Docker to your computer, which you can just do with this X host plus local Docker. This is just so you can get a GUI. If you don't do that, you won't be able to see the VC3D GUI. And then from there, I run this. Most of these can be omitted. Actually, this memory and memory swap could probably be pulled out already. But what I do is, and I would recommend this as well probably, I map my container volumes to the same location on my desktop. So like if I want to, work with a specific file, I can just go and copy the path here, and then the path is the same both on my machine and in my Docker container. And this is easier, at least for me, because then I don't have to guess, like, okay, well, Radon VME is actually Docker workspace or some crap like that. I think it gets kind of confusing. You don't have to do that. That's up to you. That's what these dash V's are. The only dash V you need is this one, the temp-x11 Unix to temp-x11 Unix. You need the rest of these, but this is all the only V you actually need. So I run it like this, which is just a multi-line command in Linux. This will also work on Windows, though. You'll have to change the backslashes, though, if you use Windows to ticks or not really sure about the one that shares the key with the tilde.
I have here one question. Isn't it like I tried it, but isn't it possible to like pipe a command into this command so that it instantly starts the GUI?
Yeah.
Because every time you have to type like bin VC3D, manually.
Yeah, it is.
I tried this and it didn't work out. I don't know why.
Yeah, let me. I think there's actually part of that in the old tutorial.
Goodbye, Tom.
Tutorial 3.
I mean, of course, I can just call the GUI every time, but
you just put the command right
me.
after. So you omit the -it, which is an interactive session. So if you have -it, that means you're going to be starting it in interactive. So if you remove the -it and the -rm, and then instead you put the n, you put after your volume cartographer edge, you put bin VC3D or whatever. That should work.
I see. Okay.
I always start interactive only because sometimes I like to just I'll run like render jobs or anything through here.
Yeah, I see.
But yeah, you could have a few commands. And then when I run VC3D, this is something I'm going to have to put in. I'm actually just going to take notes and I'll update this afterwards. So I got to update the Docker pull commands, and then I need to update this. Update command for. I'll explain what I'm writing in a second. So when you launch VC3D, if you have a ton of patches in your paster, you'll get it'll be really slow to interact with. For whatever reason, you can alleviate that if you limit the number of threads that OpenMP uses, and then you don't allow nested threading or waiting. And if you do that, you seemingly solve the problem. So I always launch VC with that, plus nice and IO nice. You probably don't need all of it, but at some point I found that this makes it faster, and so I just throw all of it in every time. We're working on getting that fixed so you don't have to use those, but for now I would recommend using those. And I'll update the guide with that. Let me just move that down there. Uh-oh. There we go. Now, whatever. I'll move to the side. And then update. All right, so once you have VC open, you can typically just get rid of these layer settings, and location for now, at least. Most of what we're doing in VC3D doesn't use those settings, and so I just get rid of them. And they also prevent this from being resized. So keep them or get rid of them, up to you. I get rid of segmentation as well, also isn't used in VC3D. And then from there, you can open a volume package. Your volume package has to be formatted a kind of particular way, which I'll show you now. If you go to, so you have to put it in a vol package like you did with traditional VC. So it has to be a directory ending in .vol package. That's the only thing you have to do to make a vol package. But then from there, it has to have a couple files. Number one, you need your config.json, which looks like this. That name can be whatever you want it to be, but you should probably try to keep it the same as your actual scroll. When it goes to render or anything, it doesn't actually matter what the name of this is, but it's easier to kind of keep track. Material thickness doesn't matter, but I would just do 150 and then whatever the scroll name is. You can copy this one from like scroll one, the config.json, and just paste it. The other thing you need...
One important thing here, you definitely need an integer version, because I missed that one out, and I figured like what is the problem, and yeah, at some point I figured it out that I need at least version 7 there.
Oh yeah, I think there's a check in the C window that sees if you have version 7 or not. So yeah, you need all the stuff. The content, yeah, for this, really this is the only one that you would ever change. It's just this name. And then from there, in volumes, you need your volumes. If you're using VC3D, they need to be in ZAR format. They can be uint8 or uint16. And within that OME ZAR, you need to have a meta.json. If you don't have a meta.json, it won't open. This also is very similar to the ones that are from scroll 1 or from scroll, like from our traditional volume packages. The biggest difference is that they have a thing called format ZAR. And so if you don't have that format ZAR, it won't open in VC3D. What I do when I make a new volume, or say I run inference or something, I just copy one from a different one, change the UUID. The UUID here doesn't actually matter. It just needs to be unique. It doesn't, there's not like if you name it something wrong, it won't open. It just has to be a unique name. So let's open, once you have all that, you can open VC3D. You don't need the rest of these. You don't need to create a paths directory. You don't need to create a renders directory or a transforms directory. You don't need to create any of that stuff. You can, but you don't have to. It'll create what it needs from that point. So if I open a volume package, you just click on the root of the vol package, just hit choose. And we will see some stuff. So this top right slice is the first one that initializes. Your other three are blank. Once you click on a segment, each one of these is a patch, which you can tell because they start with auto-grown. You can see when I click on one, you get your segmentation view, which is like a rendered version of it. It loads kind of strange at first, but you can get that to initialize the rest of yours if you control-click anywhere on that. And then you've just got to zoom in or out a little bit to kind of get the rest of these surfaces to populate. So from there now you've got all three planes. Whenever you control-click, it places your focus point, which is this like kind of circle with the dashes on it. This is the intersection at all of these planes. All of these planes are exactly the same place. So you can kind of get a quick idea of what you're looking at. And then your lines here are the same lines here. So this red line here is this red line here, this yellow one here is this yellow one here, and then this is the Z slice right here, this orange one. So there's a pretty good way to get kind of oriented in VC3D. It's not, panning through the slices doesn't always work the way that you would expect quite yet. So the primary method of shooting around in here until we get that fixed is just to control-click on different spots. At some point, that'll be fixed, hopefully soon. But for the meantime, you just kind of click on a segment, control-click. If you get, like, say you get some planes that aren't really orthogonal, and you want to be able to see, like, a good side view of it, a lot of the times what I do is I just click on another segment until I get one. Just kind of click through them, see if I get what I need. So there I got a pretty good one. At some point that'll be fixed, but it's just not quite there yet. When you do control-click though, you get this. Each time you click on a surface, it will print out in the terminal the surface's path and its UUID. And then also when you click on a surface, so when you click on a surface here, it prints that out. When you control-click anywhere on any of these planes, it prints out this click down location, and that's the volume coordinates in X, Y, Z of where you clicked. the XYZ is a little bit confusing, obviously, given that most of our stuff's in ZYX, but it's, I think, a holdover from the way VC was written in the first place. So it's just something to keep in mind when you go to do this is XYZ, not ZYX. And everything in VC3D is XYZ, at least every external interface. There are internal operations that are done in ZYX, but anything that you deal with, if you're just using the application, will be in XYZ. One of the biggest changes now that we have versus the previous version of VC3D is a sortable surface tree, which you can sort by either UUID, which is the service ID, area, the average cost, that's the total cost of the solver when it made this patch. We wanted this because we wanted to see kind of like, do higher or lower costs actually correlate effectively with good or bad patches? Haven't inspected this enough yet to make the determination, but it's something that's nice to have. And then you can view the number of overlaps that each patch has. So if you want to start a trace, you need overlaps. So it's good to have that information. So when you go to run one, you'll know if it works or not. Then from here, you also have, if you mark one as approved or denied, it'll pop up right here with an A or a D. Either one of them, it won't show both. You shouldn't have a patch marked as approved or defective, but if you did, it will only show one of the two. I guess now's a good time to just quickly address that. You shouldn't use approved or defective too much, really as little as possible, only because approved means that you were saying that every single point here is valid. Every point. Even if there's a tiny little point that you can't really see, you're saying that it's valid and the tracer will follow it. And on the other hand, defective means that all of those points are defective and it won't consider any of them. So if you do mark one as approved, you just want to make sure that you mask it quite a bit. And then on the other hand, if you do mark one defective, you want to be sure that there isn't any, like, even most of like the worst patches have some part of them that's usable. So, I mean, even if you've got to go in and mask out a significant amount of it and just keep this little piece, it's still typically better than just saying, just get rid of all of this. And it's just the points for that patch. It's not the points like in the volume itself. So it's not like super critical, but it's just something to keep in mind. So let's go through this from the start then. When you first launch VC3D, I'm going to need to pull a couple things out here. I just wanted to show what the actual traces look like quick, but we should start from nothing. And I'll show what the seeding looks like from the beginning. I just have to give myself ownership of this folder so I can move some things.
Yeah, if I want to start with nothing from a scroll, I just remove all the patches from the paths, right? Or
Yep.
how do you do that?
Yep, and that's exactly what I'm going to do. I'm just going to remove all of these
Or like you rename the path folder or something like this. Okay.
Yeah, I'm just going to rename it like pass old, you know. And then I'll make a new pass folder. You do need to make a pass folder, actually. I think I said maybe you didn't, but you do need to make a pass folder because when you seed, it will ask for it. So when you go to seed, so let's say again we're starting from nothing. We'll open VC3D. Scroll forward. We have nothing in here. We have our volumes, but we have no patches or anything like that. So the one. We have to start by seeding. Seeding is kind of a two-part process. There is the initial seeding, which just populates random seeds. It picks random non-zero points throughout the volume and then tries to grow a segment there. It does not contain overlapping information or anything else that you would need later for tracing. It's just to kind of get some stuff in the volume before the next step. That is controlled by a JSON file. This seed.json is what I call it. The only difference between a seed.json and my expand.json is the mode. So that's what controls. You could use the same JSON file and just add mode expansion or mode random seed. Totally up to you. I just like having two because then it kind of helps me keep track of them. So when you go to seed, you just need to do one of these commands. So what this does, this is an xargs command, which means it will count 1,500 times, and it will execute this command 1,500 times. So I'm going to I'm going to lower that just for time's sake to 250. The -p, this is the number of processes. I'll just set it at 16. These I'm going to pull out because I was just testing to see if they went faster. I do keep nice and IO nice. And then you'll need the executable path, which on here, I don't remember if it's mapped yet. Let's see which VC. It is, great, okay. And then the first option here is the path to your service prediction volume, which for me will be, I think S5 medial OME.zar. So I'll put that there. The second one is your output directory. In this case,
so if I call which VC grow from seed in the Docker container, I should see it, right?
You should, yeah.
Do I have to do something so that I have that, or because it doesn't work out of the box for me?
Okay, and there might be another part in the
I forgot the sec in the command. Okay.
Oh, okay. So it does show.
It's working.
Great. Awesome. Your second command then is just your paths directory. That's where your seeds are going to go. Then it's just your JSON parameters. So this double pipe to true is just saying that it's always going to return true. I only set this because I don't actually care if any of these error out, and some of them will. But I don't care because I'm just running a bunch of them. I don't want like the single one to fail and then just immediately exit out of that xargs command, which is what will happen. It shouldn't happen as much anymore, but it used to happen quite a bit. So I just keep that there. And I just copy that in there and hit enter. Now we're having, let's see, core dumped. So I think I've got my seed wrong. My JSON wrong. So let's find out. This is one of the parts of VC that you will frequently run into. I don't need that.
Yeah, the seeds JSON shouldn't be in the paths folder, should it be?
No, is that what I have?
Yeah, in the path you copied, yeah.
Oh yeah, look at that. Yep. So that is like the number one thing you'll run into when you use VC3D, and that's why I'm putting a ton of it into the GUI now. You will run into
Where do you have all these commands lying around? Are they somewhere that we can copy them, like in the tutorial?
Yeah, I do have the commands in the tutorial. So they're...
And they still match, right?
Yes. Yes. So that is right here.
Okay.
I just have these because they have my paths on them.
I see.
So yeah, this command here, this we begin volume seeding, is the same as this. I just had to edit less with this one. So now let's try to run that again. But yeah, I was saying like you're running into all kinds of problems occasionally when you run stuff from the command line, where you're just like missing something and you bang your head against a wall for 20 minutes yelling at the computer. What I do then, while these are running, instead of like opening up a folder, is I just run a watch command every second on that folder and just see if it's actually populating anything in it. So I have this also in there, just under the other command. It's in the guide. And then we just pipe the output of that to word count -l. Then I hit enter. And it's a little bit slow at first because this seeding actually operates on the distance transform of the prediction. And so every time it visits a chunk, it computes the distance transform, and then it caches that chunk. So until it builds that cache up, it is at times a little bit slow. So we're going to run this 250 times and hope we get a couple. We should. as long as I use the right path, which I did. So we'll let this run for a second. In the meantime, I'll go over the expand command. I don't actually need to run this though for the whole time. Like you'll just let this run until you get, say, 1,000 of them or 1,500 of them. And then from there, you'll end up with a directory full of patches. So we can just rename this file paths new, and then I'll just rename this paths again. So say you've got
if I run this, one question. If I run this command with the seeding and I get the error no seed surfaces found in expansion mode, what am I missing? No seed surfaces found in expansion mode.
Let's find out. Which patches are you using?
I mean, I'm trying to seed, so I don't need the patches, right?
Okay, so you haven't.
Okay.
Yep. So you don't have any seed surfaces. So your JSON probably says mode expansion.
I added mode expansion to the seed.json. Yes.
Yeah. So if you're doing the first one, right, you have no patches at all, right? Totally empty.
I have patches, but I want to start from scratch. So.
Yep. Okay. So if your path directory is totally empty and there's nothing in there, then your mode needs to be random seed. So
okay.
Expansion operates on the initial seeds. So what it does is it visits every seed. It checks the amount of overlaps that it has. If it's under the amount that you set here, which is target overlap count, it will initialize a new seed from the center of that patch and then grow outwards from it, and then mark the overlaps. So it needs to have seeds to begin with.
Okay. I'm gonna try it.
Yeah, and hopefully it starts running. It should just start running. It doesn't.
Yeah, it's working.
Great, awesome. Yep, and it's a little bit, like I said, it's slow at first, but it'll get going once you have your distance transform cache built up. Maybe after 30 minutes or an hour, and then the expansion operates on the same cache. So usually by the time you're running your expansion mode, you've got a pretty populated cache, and it's quite fast. For this part, then, what I'm going to do is actually change this, because that's not right. I'm just going to show what expansion looks like. I don't need to run the command until it's done, but let's say you get 1,000 or so seeds. I would say there you're probably good to do expansion. You can kind of check too what the density or distribution of your patches are if you go in here and just kind of load the volume up and see do I have seed patches. They don't need to be dense, your seeds, because again it's gonna run that command to expand them 1,000 or rather probably 1,000,000 times. So you don't need to have this fully filled out with regular seeds, and in fact it's probably a waste of compute to do that because they don't have the overlapping information that you need. So I would say about 1,000. Just kind of take a look at it, see how it looks. Make sure there's a couple at least, that there's some spread out throughout the volume, roughly evenly distributed. And then once you consider that good, it's time to start expanding. For that, we have the same thing. And I did make a note of that in the warning here, not to use the seed mode for the whole thing. If you fill your volume up with seeds that aren't ran with expansion, you won't be able to do any traces. So let's modify my command here. I'm just going to change this from seed to expand.json. Again, we'll run it 250 times. And that'll run for, again, you can run this for a long time. When I run my seed modes, I usually do my iterations for my seed, I don't know, somewhere between 1 and 5,000, depending on the volume size. And then my expansion, I'll run for 1,000,000. And I just kind of watch it as it goes. It will stop eventually if every single patch has at least 10 overlaps, but that could take an indeterminate amount of time. So I don't ever run it until it ends. I just run it, I keep an eye on my patches. Every once in a while I load up the volume, take a look at how it looks. It's kind of up to you. when you stop it. Really, it just matters if your volume is densely seeded. Good.
One question. I started from scratch now, and I have like 10 patches so far. How many do I want? Like for scroll 3 or 4?
Yeah, for scroll 3 or 4, like somewhere between like 750 or 1,000 for small scrolls.
1,000. Holy shit. Okay.
Yeah, it's a lot. I mean, when you finish, like my scroll 5 volume has like 57,000 patches. So you end up with a lot.
And there will be no problem if I just use your patches for seeding, right? That you already generated.
Not at all.
Okay.
No, the only real reason to use ones that are your own is like, and you could even expand on mine, is if you look at mine and you're like, well, that's not very well seeded. It's like you could just keep expanding it or run, if there's certain areas that aren't getting hit, you could run seed for a little while and then expansion again afterwards, because you have to keep in mind that expansion only operates on existing patches. And so if there's like a region that's disconnected from everything else and no patches ever touch it, you won't end up expanding into it. So sometimes you've got to, you run your seed, then you expand for a while. You notice there's a couple areas that maybe haven't gotten hit yet. When you run random seed again, it will, every time it goes to place one, it'll check if a patch already exists there or not. If it does, it'll find a new spot. So sometimes you kind of go back and forth.
Can I also set like manual seeds, because I want to like, for example, okay, this in this region, I put like 100 seed points there, and then.
Yep, you can. So the way that I do that, it's not built in, but I'm scrolling down to the bottom here. I have like a little like advanced tips and tricks section here on manual seeding. The way I do manual seeding is, and I actually manually seed all my volumes, just because I don't know. I like to just ensure that I get the area that I want densely seeded before the rest of them. So random seeding is effective, it works, but you're spending a lot of time maybe seeding out here along the casing or along the nylon wrap, rather than where you want to. Say you want to start seeding in the center. So what I do to start random seeding is I just pick somewhere along the middle Z-slice, and I try to find a Z-slice that is decently separated. And I have a tool I'm writing for this right now that'll make this a lot easier, but just to start, I literally I pull up my surface predictions, and I just control click, and I control click on all of the areas that I want to seed. From that, it will print off these coordinates, and if you take this script here and modify your paths, and you run that, it will do this. If I go to mount, I may have deleted it. I did. All right, well, we'll make it again. So let's
I
change.
guess if you're taking just a few or like a couple manual seeds, this is way better than 1,000 randomly, probably, right?
Yeah, I mean, I usually end up making probably almost 1,000 of these still. And it sounds like a lot.
Okay.
But 1,000 clicks, it sounds like a lot, but it isn't really that much. Like, compared to, you don't have to do it this way, but I like.
Compared to random seeding, yeah.
To
the
me,
random
like,
seeds can be close by and like duplicated and useless.
Yeah, they're not totally useless, but yeah, they're not always like, if you're in a volume and you're like, I want to start in scroll 5 and I know I want to start, roughly in the center, you can keep the expansion running while you're creating these new seeds and while you're making traces. Like, you don't have to stop each one of them. So a lot of time what I'll do is I'll get that like minimal set of seeds going and expansions going to where I can maybe start seeding and then or start tracing right away, versus having to wait potentially days for your fully random seeds to finish. I have a tool made that changes this setup quite a bit, but here's that. No, come on now.
.sh shell.
Yeah, yep. So all you do is copy these coordinates into there. So you take literally the whole line, including the clicked on, and just paste it and hit enter. And that'll run it on all of those.
And
That's how I
after
did
it's
it.
finished,
Yep, it'll stop when it's
Okay.
finished. It'll just run. It runs in explicit seed mode, which means it takes XYZ coordinates and just plops seeds down on those coordinates. I also put on here an offset, which you could change if you wanted to, but I essentially so you put it down at say 10 10 10. I add a 30 voxel offset in X, Y, and Z, and I run one additional seed in each one of those. I don't know why exactly I decided to do that, but a lot of the time what happens when you put a seed down is, actually I know exactly why. I don't know why I said I don't know why I said. When you put a seed down, what happens is you don't click on exactly the right spot because the focus point is much larger than you think it is, and it's actually kind of hard to tell exactly where the center is because as you zoom in or out, it doesn't really resize in a way that makes sense intuitively. So what can happen is you click here, and when you're zoomed out here, you think that's the center of it, right? And when you zoom in, you're not. And if you're even a voxel off, that seed won't get made because it won't run on anywhere that is a certain distance from the center of the surface prediction. So I added a slight offset parameter here. If you wanted to remove that, you could. This is the same command that's in here. And it's just basically a loop. While coordinates exist, run through them, run the command.
Can I ask one more thing?
Yeah.
In the beginning, you said specific windows that you don't need for the auto segmentation creation. Which one was that? The segmentation on the right, and
You don't need actually really any of them other than volume package. You can see which ones are available if you hit view.
yeah, but okay, I don't have these options yet. I only have volume package, even though they are open. I think it's the older version, maybe.
It shouldn't be.
I have all the layers and windows open, but I can only see the volume package and disable it in the view, in the drop down.
Yeah. Do you want to just send a picture in the chat of what you got up?
Yeah, sure. Okay. Yeah, like this. Now you see what I'm.
Okay.
All
Yeah.
right.
So all of those ones that are under volume package there, maybe they don't show up until you close them. So layer settings, that blank.
Yeah, that might be the reason. Yeah. Never mind. No, they're not showing up.
Weird. Yeah. Well, you can close literally all of them other than the stuff that includes from your surface IDs all the way down to edit segment mask. That whole widget you can keep, and then the layer settings, the one
Okay.
under that, layers and segmentation. You, at least as of now, won't use any of those. Most likely, I don't. Maybe you'll find a use for them,
Okay.
but I don't use them. So yeah, you can do it this way. Otherwise, I do have. I'm working on a change to the way that works. Let me just show that 1 second. Which does this. I have to just re-add it. So instead of manually seeding, what this does is computes a distance. It casts a ray from the center to the outside, and it takes a histogram of the distance transform along that ray, and then at each peak it places a point. That works quite well, but I have to get it back into the updates of VC3D. So you won't have to manually seed forever, but this achieves essentially the same thing in that I'm trying to ensure that at least one slice is not missing any wraps. So that'll be back in pretty quick. But for now, you can manually seed this way. I did it this way for a ton of time. I still do it that way right now because I don't have that thing re-added back to the new VC3D. All your settings too, by the way, when you leave, if you reopen it, if you don't close your Docker image, it saves all your settings in an ini file, And so when you close and reopen it, you don't have to like reclose those things or anything like that. And it also will keep track of your recent vol package. So now if you want to run a trace, also you can do the seeding from here. The only reason I didn't show that version of it quite yet is because it can occasionally be a little unstable. I wanted to get this thing pushed in terms of this like context menu quickly because other people might build on it. And so I wanted it before like 5 of us were making context menus at the same time. I just wanted to get one in there quick. So you could right click in there and hit expansion mode and it should run. This one isn't getting the right path. So that's part of the issue, right? So this isn't getting the right path. So it's throwing that error. I would seed from here until I get that fixed. But the biggest thing that you can do with this context menu now is you can render. So you can just right click.
This context menu is already in the latest version?
Mm-hmm.
Because I have the this version, and I don't have these context menus. Like the noble file in the Hendrix Schilling, it's like the old repository, this one.
Oh, that's why. Yeah, that's that's not the right repository. Now it's adding up. Okay.
Okay.
Yep. Now it's all making sense. I was very confused what was going on, but now...
Yeah, but this is still the one that is, I think, linked in the tutorial. That's why, yeah.
Is it? Okay. Yep. That's another neat... So let me add that too.
Yeah, clone the VC3D repository, and then there's the Hendrix Schilling link.
Yep. Let me change that. Let me just add this note quick. I mean, most of this stuff that we've changed has happened in the last like couple days, so I've got to change this guide, but this is what you'll want to clone. 1 second, let me copy the link there. The scroll, we have our own now. It's hosted under the Scroll Prize one. It starts from that dev next fork in Hendrix. So you should have it there. You can do the Docker pull that way now if you want to try it out. You just have...
Yeah, I'm trying.
I'll just copy the command into the Discord if you want. But yeah, once you get it, you'll see that at least for now, the most useful thing is the render, because if you right-click render a segment, it will render it and it'll copy that path into your keyboard or your clipboard, and then you can just, well, if you haven't copied another thing after that. Also, we fixed the normals. Before you would end up with backward segments, but that's fixed now. We're flipping the normals properly when we render, so you don't end up with backward segments anymore, which is pretty handy.
What do you mean with rendering? Is it like running a trace, or?
Rendering is just sampling the points along the mesh, basically. So it has to visit every single point in your mesh and then sample the texture from the actual volume and then put it in your UV, like in the actual like texture map.
But isn't it already rendered in the left top
sort of
visualization?
Yeah, in a way. So it has to do essentially the same thing when it renders this, but this is a downsampled version, so this is the 2 times downsampled one. And in this one, it only renders the middle layer. So it is rendered, sort of, but when you want to fully render it in the higher res one, you have to actually run VC render TIFF-XYZ, or come up in VC3D and then just right-click render segment, and then it'll show you here.
Why would you render only specific autogrown segments?
I mean, there's a ton of reasons you might. You can render your actual full traces, but I render patches a ton, especially in a volume that isn't scroll 4, that isn't so easy to get large unwraps for. Like, we have more or less auto-segmented the entirety of scroll 4, so scroll 4 probably isn't a good example of one that you would do that in. But scroll 5, on the other hand, we have not. And so there's areas in scroll 5 that you might want to get like a patch from, or even if not a patch. 1 second, let me just get this pulled up. This will take a second to open. But say you wanted to get like ink training stuff, and you didn't want to like run on giant segmentations or like big segmentations in the areas outside of like the Grand Prize region, or on the segmentations that we've made for Scroll 5, if you wanted to get like training data from outside of those. A lot of the times you can get patches that are 5 to 10 centimeters that are all over the scroll. That's what I made these. If you go to, let me grab a window here.
Yeah, the patches that you uploaded, right?
Yeah, exactly. If you go to community uploads, Brunus, ink train patches. Yeah, so I've got like, I don't know, 39 or 40 of them in here, and that's what these are. They're just patches. So I just rendered them and ran ink detection on them.
How do you specify with the rendering how many layers, like 21 or 65?
Mm-hmm. Yeah, you would do, so the command takes, I'll just open up another Docker container and show you. If I can find my other text field, there it is.
It's funny how you're having like 100 commands in a text field.
I know, right?
Like, how you gotta do it.
That's why I'm trying to put it in the GUI now, because trust me, it's a pain to keep track of all of your commands. If the only one you have to keep track of is your Docker run command, it's not too bad. But VC render TIFF XYZ takes a number of potential arguments. The primary ones that you would use are these last three. So you would do your...
If I run it from the GUI, it doesn't work yet, right? It takes
no,
like default.
It just does the default of this. So you would do like path whatever, output path, and then this would be at one scale of 1, so it doesn't upscale or downscale. 0 is the target OMEZAR resolution. 21 is the number of layers. So if you wanted to do 64, you would just change it to 64. If you wanted to use the downsampled version, maybe 1, and then if you wanted to make it smaller, you could do like half scale.
What if I'm like, let's say I'm using scroll 3 or 5 your patches, but I want it on a different volume, like the other, you know, there are 2 different quality versions of the volumes, like the micrometer, you know, resolutions.
Yeah.
So, for example, for the scroll 4, where I pointed out to you that it's the other version, is it possible to take these patches in the other volume and render them? Or like these segments?
Not really, not easily. You would need to compute an affine transform. You could use the one that exists, but you'd have to manually code the affine in the loop that does the actual sampling.
So if I want to do it for another volume, can I still use the same, what is it, the multi-ensemble predictions from you? Like the...
It would be the same thing. Yeah, you would have to, you'd have to do the same thing. You'd have to compute the affine for it, because they're not going to line up. They're not registered. So, yeah, no, you can't, I guess is the long and short of that.
Okay.
I don't think though that I do not think that is the high res version. I believe you when you say it looks different, but
I've taken a lot of time looking into it and comparing it, and even the meta.json says, you know.
Yeah, and the meta.json though, the only reason you could be right. Like, I'm not saying you're wrong, for sure. But there's a good chance that like I pulled the meta.json by just like literally I was like, oh crap, I need a meta.json. And I just went into here and I just ripped open a volume and just sorted it and just grabbed meta.json and literally just copied this. Like, the meta.json was made by me just creating it, you know. It's not like it was made programmatically.
But if I want to make sure, I could take the other volume and just make segmentation from ground up.
Yeah, 100%. Yep, you could just start from that one.
But the surface predictions that I can use from the scroll 4, can I apply them to both volumes, or do I need new surface predictions?
So I know that. So let's say that one is ran on the high res. I do have surfaces from the old ones. These ones I'm 150% certain are the low res one. If you do these surface regular or surface erode, they're not as good as the new ones, but if you wanted to they're probably good enough to get a segmentation in the same area and figure out for sure.
Okay, so this means I need a new surface prediction for the other volume, right?
Yeah, but I have one. I've already made one. This one right here.
Okay.
These two, they're not OME ZARs yet, though.
Is there some meta information or like README about to which volume they belong to? No, right? I think you
No,
didn't do it.
outside of like I've sorted them by like scrolls, S4, and then that's
Yeah,
an
but
archive.
the scroll has multiple volumes, so
Yeah, no, there's not that. I made most of these like when I was still a contestant, in like,
yeah, I see.
I don't know, August or something like that, maybe September. So when I was doing those, when I was like a contestant, they need to be cleaned up. Trust me, I'm aware. This folder's a nightmare. I didn't have that like in mind when I was making them, that like eventually these would become like the canonical surface predictions for like the challenge. It just wasn't. I was focused on like trying to do the challenge at the time. So I haven't.
Okay.
They need to be cleaned up though. I fully admit to the fact that directory is an absolute disaster. But here's an example like in scroll 5 where you might want to do that. Like say you sort these by size, right? Oh, I hit it too fast. So now you can figure out, okay, maybe I've got some segmentation, some patches here, and this patch is 12 centimeters squared, so it could contain a pretty large amount of text. And maybe this is outside of a region that currently has an auto segmentation. Or maybe you just wanted like a small sample of a diverse data set, because the patches in most cases are reasonably high quality, in some cases even higher quality than the traces that come from them. So sometimes it makes sense. I like to do that because when I train like an ink detection model, what I want is a diverse set of high quality data rather than a huge set of essentially the same data. So that's kind of why I would consider doing this, unless you have auto segmentations that cover the entirety of the scroll, like scroll 4. Outside of those instances, I typically actually think it would be better to have less but more diverse data than it would be to have a ton of exactly the same data, like you would if you just took all of the ink detection in all of scroll 1 grand prize region and ran that. I think that a model from that would be worse than one that had way less data but from all over scroll 1 by sampling patches.
I see.
That's my thought on it. There might be different schools of thought on how to train ink detection models, but that would be, I guess, my reasoning for why a person might use patches. Or say you were on a scroll that didn't have large segmentations, like scroll 3, and you wanted to find letters. Say you wanted to win the first letters prize. You could just sort these by size or by cost or by UUID, and you could just literally tab through them. Just hit down, look at it, render one, run ink detection, hit tab. You can just kind of move through a significant amount of the volume very quickly. And I think this is probably going to be, especially as we get more volumes out, the primary method, at least it will be for me, of discovering ink in new scrolls, in that like.
But in this way, you never know where in the scroll you're really located, except for the. Yeah. Okay. Well, you know where.
Yeah, you just click. Just control click and it'll show you exactly where it is.
Okay, but if you have two patches that are overlapping, how could you fuse them then?
How could you fuse them?
Yeah, you can't. You're running a trace, right?
Yep, you would run a trace, exactly. Yeah, there's not like not yet at least. That's one of the issues that I've put in the GitHub is like a way to like, maybe manually connect two patches together to either indicate that is the correct path for the trace to run, or maybe for what you're saying, where you just say, hey, just slap these two patches together and do it that way. You'll know roughly if you're in the same area because patches are usually like grouped sort of by UUID. So if they have like similar UUIDs, they're usually like made. That means they're made around the same time, and they're usually made around the same spatial location. So if you sort them by UUID, you usually end up roughly in the same area. If you sort them by area, you still could be, but less likely. You'll know if you're in the same area because when you click on the next one, you'll have VC3D holds a cache of the volume data when you tab through these, and you'll know if you're right next to the other one because it'll load literally instantaneously. If it takes a half a second or something like that, you're probably away from it. Like this one was quite close. You could also see here if you go to this thing. So these two were 200Z apart or 200X apart, 500Y, and only 800Z. So they were quite close. But this is just one way to do it. Again, I think that this will be the way that people probably find ink in new scrolls, in that like it's probably likely that all scrolls contain, like in scroll 5, like scroll 5 has text on the outside that's like insanely visible, and then text right in the title that's insanely visible, and then something in the middle where, if we had spent 5 months manually segmenting the middle of it, we might have never realized that scroll 5 contained ink that was just screams off the page. And there's a similar distribution in scroll 1 where some of it's super visible, some of it, if you had only spent 6 months looking at that area, you probably would never have found ink. So presumably the fastest way to find ink is to just look at a whole pile of patches from a bunch of different areas.
What we are looking right now at is the composite, right?
Nope.
No?
No.
Is it the middle layer?
Yeah. The patches look fantastic, man. 90% of the time, the patches look great.
And you can just see the ink in the middle layer. That's what you mean?
Mm-hmm.
Oh, okay.
Yeah, this is not a composite at all. You can't see the ink in all these places. I don't really know. If I picked one on the outside, it would probably be easier. But yeah, you can see ink just on one layer frequently in scroll 5 and in scroll 1. The ink's not that thick, It's only...
Yeah.
The only reason it seems so much thicker is because it's when you look at a flattened segment from a segmentation, like it isn't truly flat. Like we've flattened it as much as we can, but at the same time, it curves, and so 32 here is not 32 up here if it's curved and the segmentation line wasn't right. And
yeah, if it's a perfect segmentation, probably the ink is around 4 layers or something.
Yeah, somewhere between like 4 and 10 probably, but even 10 is probably on the high side. It's not that thick. Where it does get thicker is when it curls up. Sometimes like you'll see in the crackles, like they'll curl away from the page, and they can curl away from the page really far. But on the whole, in that letter, the ink isn't that thick. It's just parts of the crackle. So yeah, that's I guess why I would potentially do seeds and patches. But let's say you don't want to do that. You've got your seeds done. You ran your expansion mode. If you want to run a trace, then all you've got to do is find your trace command in your giant list of commands, or pull it up from the segmentation guide if you can find it somewhere. And go to running a trace. So from there, we just pick a seed patch. I'm just going to pick the one I have open right now. Let's see kind of where we are. Sure, let's start from there. So we get the name of it, from here.
So even though it has holes, you're choosing this one.
I'm
Or
only
what-
choosing
what
this one
was-
because I
what
have
is-
one up. I guess, yeah, let's go over what the best way to do it would be. What you're looking for in a trace patch is one that, if you have a location you want to pick, I guess, let's start from there. So let's say you want to trace a specific spot. What you can do is zoom in where you want to go, control click to set your focus point. Let's say we want to go somewhere around the title area, which is like 5-6 wraps out towards the center. And then you can hit filter by focus point. That will take a little while because it's got to go through 50,000 patches or whatever, 43,700. And then it will only show you the ones that intersect with your current focus point. So then from there, I know I want to go here. Now what I want to do is I want to try to find a patch that's good. And by good, I mean has minimal sheet switches or holes. You're not ever going to find typically a perfect patch, so you're just looking for one.
How do you see sheet switches in here?
They show up a couple different ways in VC3D. So number one, the way I find them typically is by trying to follow fiber continuity. So if I can follow a fiber for the whole width or the whole height, typically I assume that it is not a Z switch, or a sheet switch rather. That's one way. It's just kind of looking at fiber continuity. And if you want, you can pull up a fiber volume. It doesn't go out this far though, so I can't look at it in this one. But we do have fiber volumes published. I think I might just have this one loaded wrong, but you could load up a fiber volume, which gives you a kind of an easier look at it. So you've got fiber continuity.
Okay.
You've also got, let's see if I can find a good example like this. So see how these don't connect down here? That means that either this is sheet switched or this is sheet switched. Probably this one because it doesn't connect here either. So this is probably wrong. VC3D doesn't like silently sheet switch usually. What'll happen is you'll just get these gaps, and you can see that in the traces too. If I pull up one of the traces in here, let's sort them by Beard 172. I don't know why it's not showing them anymore. Yeah, let's just pull one of these ones up then. Let's do.
By the way, in the new version, it's all working now with the menus and everything.
The new version. Oh, it is working?
Yeah, the new Docker, the updates were missing in the old version, so yeah.
Okay, great. Let's just pull one of these up. I'm just trying to find one that would be a good example.
One question aside from that, could it be possible to create like a thread or something in the Discord where just basic questions for VC3D could be asked instead of in general and, you know,
Sure. Yeah. Absolutely.
like a sticky thread or something somewhere, or like a channel, or I don't know. Maybe you
Yeah.
have a better idea. Because I never know where to ask questions like this.
Yeah.
That could also help other people.
Yeah. I mean, I'll make a. Why don't I just make one right now? I'll just make a post in segmentation.
Because this is not only just a proof of concept anymore, it's like a full software program.
Oh yeah. Yeah. It's coming along quite a ways. Here, I'll make a post right now.
Okay.
Questions. Just a second here. Perfect. Okay, so I just made a post in, and I'm probably going to edit the content of the body a little bit later, but at least there it is. It's just in segmentation, VC3D help questions. So if you want to post whatever you want in there, you can also post in general. Like you shouldn't be like necessarily like afraid to post in general. Like I know that we do have like sorted threads, but like you can ask whatever you want anywhere, man.
But there it's kind of lost, you know.
Yeah, no, I get it, right? It is hard. We do have a lot, and it is hard to kind of keep track of stuff. So yeah, this is a good idea. But to the point of like sheet switches in VC3D, like it doesn't fail or it doesn't sheet switch quietly. You know, like when it sheet switches, what'll happen is like it can't reconnect this to this. You know, and so there's this giant black line that goes through, and that's how you'll know, at least in larger traces, but it's true even in patches, that something isn't right. You know, it's sheet switched somewhere because it isn't able to reconnect those two because they're on opposite wraps as they go down in Z. And so that's usually a pretty quick way to know. Like if you're running a trace and you're looking at it as it goes, like say you started, you know, way back here and you're like, okay, we're going great. Here, all of a sudden, now we're starting to sheet switch, and it occasionally will fix itself like it did here temporarily. But once you start to sheet switch, it typically will continue to sheet switch for a while. So at that point, you would want to like mask probably the area where it did sheet switch, which I'll show you how to do in a second. Or, yeah, I mean, that's what you would do. You'd stop the trace, mask it, start the trace again. So let's start from, you know, you want one that's like a somewhat decent size. Let's just say this one. So this area up here might be a little bit of a sheet switch. We can fix that if we hit edit segment mask. If you have your default image viewer here set to GIMP, which I don't, so I'm going to have to change that. Oh wait, no, I do have TIFFs associated with GIMP, I believe. Although I'm in the Docker, so that's right, I've got to do that. I forgot there's one more intricacy with the Docker. You've got to install GIMP on the Docker.
Wait, how would I do this if I'm in there via Windows and I'm not using GIMP, like Paint?
You can use it through the Docker still. You can just do apt install the GIMP in the Docker.
Oh, okay.
And then you can use GIMP through that, which I just had to do the same thing. And as long as you have X11 forwarded properly, which you do if you have the GUI up, it will just forward GIMP through that. So let's go back to there where we were. I'm just sorting the segmentation list to try to get I know the one that I was looking for was one of the near the larger ones, so I just want to get back on a Z level that's clean, which should be there. Perfect. So again, we will select a focus point, filter by our focus point, and I'm actually going to select one that's a little bit smaller, only because when you do the edit segment mask, it actually renders that slice. And so if you use a really big one, it'll take a little bit, not like a super long amount of time, but enough time that like for the demonstration, I don't want to use one that's absolutely massive. So let's just pick this one, and then it'll render whatever your currently selected volume is. I'm going to just pick one that's smaller, which is the prediction volume. And then I'll hit edit segment mask, and then we should see it rendering in the back. And then hopefully it will open GIMP, which it did. So this GIMP is running from Docker. This is not on my machine. To mask them, I'm going to mask out. So I selected one of these. I'm going to mask out the parts that are bad just to demonstrate masking. You select your page 1, set your opacity to like 50%, somewhere around there. Then select your background page. Select your brush. Set your foreground and your background to black. And then make sure that your hardness is 100. And then you can kind of manipulate your size up. So for this, like, I use a pretty big one because I am a generally aggressive masker when it comes to this, because all of your patches are overlapped. So like, if you remove maybe a little bit too much, it isn't that big of a deal. But this is all you're doing then, is you're taking a black brush and you're just painting. So I'm going to just mask out these like 2 areas that I think are kind of bad. Maybe this one down here. I don't think that whole area is bad, but let's just say like that. And then all we have to do, maybe I'll take this to, all we have to do is hit File, overwrite mask.tiff. Then we can close it. And you could run 2 Dockers at the same time if you wanted to, if it were easier that way. One with GIMP and one without. I didn't need to launch VC3D again because it was already open, but I accidentally hit Control-C, so we'll wait for that to load again. Once that's done, when you mask something, it just saves a mask.tiff, which is exactly what you just did. What I'm going to do, though, to start this trace is I'm actually just going to go back up because I just masked this and I don't want to pick a different one now. So let's say we selected our surface in our area, we masked it, everything's good now, we're ready to trace. What you need is the path to your source. The command is also in here, and this goes through kind of what we were talking about. It's constructed in, I'm going to pull up my, because it just has my paths. There. So it would just be VC grow seg from segments. The first one is your OMIZAR. I have right now I have this copied, so I'm just going to paste this in here quick and then I'll go through the rest of them. So the first one will be your OMIZAR. So wherever you have the actual data that you're tracing on, which is going to be your OMIZAR for your surface predictions. So I'll copy that, which for me is this, S5059 medial OME. Copy that as your first. Your second is the paths to your target directory, which is the directory that contains your traces, which for me is just scroll5.voltPackagePaths. The third one is your output directory. For me, I create 2 different vol packages because I like to watch my trace as it's running, and I also don't want to close VC3D at the same time. So I create 2. One of them I just output traces to. So I symlink the volumes to the other volumes, and then I just run my traces into the paths. I'm going to rip these out of here because you can't have ones in there when you start it, but that's mine. So I'll do scroll5dbg.voltPackagePaths. You can do this as well if you want, or you can just output these to the same one. It's entirely up to you, really. I like to do it this way, again, just because I like to watch my traces run, and then I also like to keep the one with all the patches open because, say this trace on this seed isn't good, I'm going to have to find a new one, and I don't want to have to like close and reopen VC3D a bunch of times. You maybe don't need to do it so much anymore because now there's a refresh button in VC3D, but you used to not be able to refresh the segmentation list. So when you would run a trace, if you wanted to see it in progress, you would actually have to close VC3D and then reopen it every single time. With the refresh button, you probably don't need to do this anymore. I'm just kind of doing it out of habit. And then this final one is just your actual source segment, which is the target that you're going for. So this is the one that I selected, which I got from right here.
Could you, for this command also, because there's only the copied command, like one example in the tutorial right now, but it doesn't say what like each path is, you know? So I was really confused and like, okay, why are several paths like double and twice, you know?
Yeah. The easiest way for a lot of those is like to just enter the command. In this case, apparently I need to do bin. Oh no, I didn't. I just typed it wrong, and it'll print off what they actually are. But it is a little confusing. What is source and what is target, right?
Yeah.
So yeah, I could enter in there. Let me make a note of that quick. Where did that go?
Like a bit more description for what the
Yeah.
parameters are and
descriptions for parameters. What they do. Yep, I'll add that as well. That's a good idea. Yeah, because it is a little bit confusing.
Thank you.
So let's say now that we have our command completed, we're ready to start a trace. We should be able to just paste it right in here. It's going to output to my dbgval package. It prints a couple things. Very shortly, though, this is going to it's going to print so much stuff that you're not really going to be able to follow it, and that's okay. Really, the only thing you're looking at is this area. If it's growing, this will continue to grow for an infinite amount of time until it can't anymore. When you see this is the actual windowed optimization step, which is that like it adds patches to the grid, and then after it reaches a certain amount or a certain amount of cost for adding them, it will run an optimization step. That's what this is, and that is controlled by the parameter in the params.json, which is, I got way too many things open in text editor. Right here. Most of these are manually ones I was testing out, so most of these you're not going to see in here, but you'll see like this amount right here. Come on.
Is there also the documentation for all these parameters somewhere?
There is, yeah. So there is in Hendrix. Oh, this is not good. The text editor in Ubuntu is problematic, to say the least.
I guess all the parameters are a good thing also in the JSONs to, I don't know, describe them somewhere.
Yeah, most
and
of those
when to use them and when not, yeah.
Most of those you wouldn't use, but you can, and I will detail them in that. I wouldn't recommend messing with too many of those most of the time, only because a lot of the time they don't help, and then they're not going to be better than the original one, and you might forget which ones you changed. But you should play with them. Like, they're fun to play with, but like I wouldn't get too crazy with them.
Why do you need flipx?
Yep. So that's what these are. So yeah, flipx is when you start a trace, it's going to go left or right, depending on the way that the patch that you're selecting as your source patch is facing. What it's I think it just bases it on the normals. So if most of the normals face out, it goes left is one left, and if most of the normals face in, left is a different left. And so if you want to trace out or in, the trace always goes to the right. But the right is different depending on which way the normals face. So say I was starting in the middle of the volume, and I wanted to trace from the middle of the volume to the outside of the volume. I would start a trace and see which direction it goes. If it's growing inside and my flipx was set to true, then I would set flipx to false, and that would force it to go the other direction. And that's the primary use of flipx, is just trying to figure out what way the trace is running, and then influence it to go either the opposite way or keep going the same way.
But don't you know the direction after you started it or like inspected it? How can you stop it, flip the boolean, and then like continue?
Yeah, you wouldn't like stop and then start again like that. Really what you would do is start it, check if it's going the right way. If it's not, delete all the stuff you did, and then
And restart.
it. But you check it right away. Like usually when I start a trace, the first thing I'll do is open VC3D, and then I'll go into my volume package. Let me just get it pulled up. So my scroll 5 DBG one, which is where I'm outputting my traces to, or I should be outputting my traces to. The fact that it isn't there is a little confusing. Hold on. No, I'm outputting them right to the, right to the vol package. Nice. So let's do this quick. So I entered my command wrong, but I'll stop it now because we don't need to let it run forever. But I'm going to just this is the only thing about the Docker that's really annoying. At least in Linux, you have to run Docker as sudo, and because of that, all of your files are owned by sudo, and so you constantly have to do this command to give yourself ownership of it before you can like move or delete them. So let's say I pulled this up right away, right, rather than like waited a while. What I would do if I was trying to figure out what direction it was going was just look at like 3 of them in a row. So say it started at, I pulled it up at 47. I look here, and then if I click on 50, 100. Okay, now I know it's growing out because this wasn't here before, this orange thing. And I can see it's continuing to go out. So if I wanted to go out, I would leave flipX the way it was. If it was going in, I would just change flipX to false and then restart it. But I check it pretty early on just to avoid having to like start it and then stop it again.
Okay.
But I mean, you can see it grows pretty fast. Like that trace, I don't know how long I was running that for, like a minute and a half or 2 minutes or something like that. And we've got a pretty significant amount of surface already. So it isn't really like that critical if you run it for a second, stop it, run it again.
Is there anything you can do about the holes and sheet switches, like postwards?
Not afterwards, really. Yeah, yes and no. So you run your trace, right? And these ZDBG gens are intended to be an intermediary, like, output of the tracer. So we've ran our first trace, and yeah, we've got holes. So if we want to infill those and potentially fix some of these sheet switches, what you would do is you run 2 or many traces, and as you do these, initially what you would want to do is mask, really, because what happens with your sheet switches is you have an area where it's gone onto the wrong surface, and you want to fix that, obviously. So what you would do is you can take your trace and you can put it in your regular paths. And I've got that open here, so I'll just reload the surface volumes quick, or the patches quick. And I just put that one in here. And then I would just find my DVG, whatever, 31, 32, or mine was actually 288, but these are some other ones I had ran before. So let's pull this one up. Oh yeah, these are some of these outer ones. Okay, so let's say this is a sheet switch here, right? Which it probably is. What I want to do is find out which patches did it use, and do those patches contain sheet switches in that spot. And so you can set your focus point to where it's gone wrong, and then filter the patches.
Setting the focus point is Control-click, right?
Yep.
Okay, because it's Control-Shift-click and Control-Shift-Alt-click and
Yeah.
like a lot of different clicks. So.
Your primary one is Control-click most of the time. But yeah, it is a little confusing. I'll concede that. So yeah, you select where it's gone wrong, and then you can inspect your patches like this by looking at them here. Or you can do, what I do a lot of the time is these are now all the patches that intersect with that location. And I'll just pull them out here and inspect them and see which ones are wrong. So say this one has probably a sheet switch here. I'll just hit edit segment mask. And the good thing is the tracer is pretty like deterministic in the sense that like if you run it and then you mask this area, it will go to the same area. So your fixes will actually apply to the area that you're wanting them to. It's not like you run it and then it just picks a totally different path the next time, and then your masking didn't do anything, you know. So you just pull that up, say I don't want it to go there anymore, literally just draw it out, maybe here, hit save, overwrite mask.tiff, and then start your trace again with the exact same command you used before.
But isn't just not going there by masking it really a solve or a fix?
Most of the time, yeah. And the reason for that is like most of these patches, so we have, I don't know, what is this, 15 patches or something like that, that all go over the same area, and they don't all make the same mistake. So
okay.
what you've got to do is just, you're trying to tilt, it's basically just like a statistics thing with the tracer, where it's like, we hope, it works on the assumption that, you know, if you trace over the same area 10 times, 6 out of those 10 are going to go the right way. So where it does sheet switches, most of the time what's happened is maybe 6 out of the 10 of those go the wrong way. And so you're just trying to tilt it back the other direction by masking out the ones that are wrong. So maybe
is there a way to manually fix the sheet switch for this, or you don't do that?
There's not right now. That's another kind of like target I have for the issues list, is a way to like manipulate these just like you would in older VC or in Cartez. You know, if you could influence these like you could in Cartez or VC, that would probably be a much easier way than masking. Right now, masking is the way to do it. The other thing you can do though, and this is something that I do quite a lot, is rather than masking your individual patches and marking out the places that are bad, you can take a trace, so say this is the DVG gen, and you can just mask out, like, you can erase everything but like a really good middle section, and then mark that as approved, and then you know that it will go on that path. If it's marked as approved, the trace will always follow that point, no matter what. So if I know for certain that like this area is good right here, I could mask out, erase everything other than maybe this little band right here. And a lot of the time what will happen then is that acts kind of like almost as a regularizer for the optimizer, in that like, even if it starts to go off over here, it has to fit this to that part that I said was good. And so more often than not, if you have a few of those, it just won't go the wrong way, you know? So I'll do that occasionally. I think I have that marked. I'm almost certain I have that down here. Yeah, right here, checkpointing, I called it. It's a little bit convoluted. It's another thing that I want to get put into the GUI. But for now, it's kind of a manual process where you run your trace, you hit edit segment mask, you erase everything but your really good area, then you've got to rename it, update your meta.json, run another tool, mark it as approved, and then start your trace again.
But one question, what you just said with like approving like a part of the segment, I think we are not running the tracing on this DBG generated, right? So what does the mask help here?
Yeah, so something to know about VC3D is all of these are technically the same. They're all TIFF XYZs, and all of those TIFF XYZs are formatted and written in exactly the same way. The only difference between a trace and a patch is that one is named ZDBGgen and one is named autogrown. The trace can be a large patch, all you need to do is give it some of the information that a patch contains, which is the overlaps, which you can get with VC SegAdd overlap, that tool here. By default, they don't have that information, so you need to
so if you would run it now on that trace,
it won't do
would
anything.
get overlaps.
Yeah, it won't do anything. Oh, yeah, if I ran that on that trace, it would. Yeah, if I ran VC SegAdd overlap on this trace, then it would have overlaps. Yep.
So the workflow with continuing with this first trace would be, okay, we mark that region with approved, then we add overlaps, and then we rerun, maybe starting with this segment, this patch even, right? With the trace.
You could. The only issue is if you start from a patch, when you select a source trace, it starts from the centroid of that mesh. And so if it's really long, say this thing is, this long, your trace will start from the center of it, so you won't get the beginning. So I typically actually just rerun from the same place, the same one that I started from before, but now because I have all those areas marked as approved, by like effect, I've made it add that, because the tracer, if it sees a point marked as approved, it will always add it.
Will it skip some region if I mark it as approved and like continue outwards from the mask?
No, nope.
It still starts in the approved part.
It starts in the part where your trace is. So if say your patch that you're starting from is actually way over here, right? I don't know if you can see my cursor, but say that you only mark this part as approved, but your source patch is over here. It'll run the source patch as usual. It'll trace like normal, and it'll just keep going, and then it'll go, oh, found this. It'll say found SM whatever approved, and it will add that point, and then it'll just keep adding all those points as it goes. But it'll also keep going.
It has to reprocess the approved patch anyway.
Yeah, but it's instant. It doesn't have to do any kind of.
Okay. Mm-hmm.
It's really fast. Like when you mark one as approved, it doesn't take very long. If you end up marking decent areas as approved, you'll end up going pretty quick. And what I try to do is I'll make a lot of the times, at least on all the scrolls that we have, the bottom is usually really clean, and you can get no sheet switches along the bottom for a huge amount of length, and I'll mark that whole thing as approved. You want to be careful. You want to make sure there isn't sheet switches on it, because if there are sheet switches on it, you will not be able to get out of it. It will sheet switch every single time, because it won't consider anything else. It will just say it's approved, and it'll go, fine, I'm listening to you. You said it's approved. But I'll mark that whole thing, and then again, it kind of almost acts as like a regularizer for the rest of it, because it has to fit the rest of the patches, the rest of the trace to what you've marked as approved. So, you make a long band on the bottom, or somewhere here you make a really tall one. They don't need to be huge, but you make a couple of those, and they can really help your trace quality. But I always run from the original.
If you approve some regions, do you include holes or not?
The holes are fine. If there's a hole there, I usually will mask the hole out though, just because I don't, I'll figure that, okay, well maybe here it's made a mistake, right? So when I mask out a mark an area is approved, I'll take a hole and I'll mask out an area around it, kind of like a radius around it, just in case maybe it made a mistake right here, and now I have a hole here, and if I mark this approved without masking this, it won't fix that hole. But if I mark the radius around the hole, then it will fix that hole, hopefully.
We only have one mask for a segment, right? And we can say either the mask is a good mask or a bad mask, right?
Yes. You don't actually even need to make a bad mask. The mask is just a Boolean. Where it's black, it's good. Where it's good, it's bad. If you want to make
if you make an approved mask, that's what I mean with good mask.
Yep.
Then we can't make a second mask for what you just said for the holes, right? So we have to mask the hole in the patches or in the other patches?
No, you can mask the hole in the thing. You can make here, I'll just do it real quick.
So, yeah, okay. But how can I do different regions? One is good, one is bad in a mask?
Yeah, yep, I'll show you. 1 second here. This will be up in just a bit. So because I selected the actual data volume, it takes a second to open. I usually try to select whatever my currently displayed volume is before I mask. I try to select the surface ones or something like that, so it doesn't take so long to render. you're curious where this output comes from, it comes from a function called read interpolated 3D. If you ever end up digging into the code. One more thing, if you do make your approved areas, you need to change the naming of the segment that you're going to use. It needs to start with autogrown. If it doesn't start with autogrown, it will never find it.
Oh, so the ZDBG's gens, they are not considered?
No, you would have to rename the folder to autogrown, and then in the meta.json for that, you have to rename it to autogrown. You can call it autogrown, ZDB, gen, whatever. You can call it autogrown whatever you want, but it has to start with autogrown.
So if you iterate towards an auto segmentation, a full scroll one, you always have to do that?
Yeah, you don't usually have to do this that many times. Like the trace, on like that one scroll 5 one that I did, I maybe did this 4 times. Like it's not a lot, you know. You do a little bit of mask patching, a little bit of these like larger ones, and it kind of like settles in. You know, you don't have to the trace like over a whole scroll doesn't make that many mistakes. You know, you're really only catching like as you trace one, you usually have like a couple problem areas, and those areas you focus like some extra time into, maybe doing this or masking your patches. But it's not like you have to do this over the entire scroll usually. So what I've done here now, so now when I make this mask, this entire area I'm saying is good, right? I'm saying everything that's white is good. I can also then do this. And I'm saying this is bad, but that doesn't mean that it won't go in there. I'm just saying don't say that. I'm basically just saying, like, I'm not saying this area is perfect, right? I'm saying all the white area I think is perfect. Anywhere that's not marked white, do your thing. Even if it's fully encapsulated.
Kind of similar to the ignore mask thing we used.
Exactly the same, yeah. Yeah, I'm not telling it anywhere what not to do. I'm only telling it in certain areas what to do. So you can make this kind of shape whatever you want. The only thing that I don't do, and I honestly, maybe you can do this, I've just never done it, is I don't know how well it works if these are like not contiguous. Like if I just did this. I think it would be fine, but I've never actually tried it.
Yeah. Also, why wouldn't you take like in the left side, the whole column? There's like one column that you could take?
Yeah, up here. I probably could.
Yeah.
The only reason I didn't is because of this. And this might not actually be a problem, and I could have maybe just masked this little tiny area out. Right?
A bit more to the right, which is contiguous to the top and to the bottom. No, on the left side, but like 1/3. If you scroll out, there's like one column that you could take further to the left.
Here?
Yeah, like this. There's like a whole column that is contiguous.
Yep. There's no reason I couldn't have taken that. Oh, what the heck? Hopefully that's still going. My headset made a sound. Can you still hear me?
We can't hear you yet.
No. 1 second. Maybe now? Can you hear me now?
Yeah, no.
I don't know why my headset did that. It like turned off. The only reason I wouldn't have taken this one down here is this does look like a sheet switch to me, right here.
So we are missing something there.
Something ain't right here. Up here, though, I probably could have taken. I would have masked this little hole out, but I probably would have taken this entire height. I just wanted to show as an example quick. You can take, it doesn't have to be like a perfect shape. Like you can take, and you should take, you know, as much of the good stuff as you can. You just want to be sure it's good.
The more I take, like contiguous areas where I'm sure these areas are no sheet switches, the faster it theoretically gets the next iterations, right? Because it skips these areas, and because I say I'm fine with this area.
Yep, that's correct. Yeah. The more, and also the better the stuff around it's going to be. You know, like this could be because this is good, it's likely that this stuff will be better too. You know, like it influences all of the stuff around it. It makes the optimization problem easier if you know they're correct. It doesn't have to try to fit points that probably shouldn't be fit. And so it's
No, but I'm wondering why you're not adding more white regions, like on the top right, like a small one, or like, you know?
yeah, no, I mean, in this example, I'm just not adding them because I just wanted to show quickly what would happen with the whole. If I were doing this for real, yeah, you could add a whole lot more.
Yeah, if you're
Yeah.
doing this for an auto segmentation, like a full scroll one, how
Yeah.
do you?
I would add more. Yeah, I would have not erased everything on here. So I would have maybe gone.
Okay.
I tend to lean though still on the side of caution because again, if you say it's good, it's going to consider it good, and there's like nothing. It won't recover, you know.
Mhm.
So if I were doing this for a regular one, I would still almost certainly erase all of this. I'd maybe leave like that. I would
And also,
probably,
if you see some weird stitches on the surface, right?
yeah. Most of the time, the tracer is like this is definitely a sheet switch, but sometimes if I see like this stuff, it doesn't necessarily mean it's a sheet switch. It could just be a meshing artifact. But for me, I don't want to take the risk because I don't want to give it anything that I'm not certain is correct. Because I don't want to. If you give it some stuff that you're not certain is correct and it makes mistakes, then you've got to figure out later. Okay, well, which one did I mask? What way? Why won't it go back to the right place? Like, you can end up in these like kind of like loops where like you've kind of like committed. You know, you've given yourself a problem that maybe wouldn't have otherwise existed. So you can take a lot. It's just you want to be like something like this. Maybe I would do. You know, I'm not confident in most of the bottom of this one because it sheet switches over here. It probably is wrong. And then I would give maybe something like that. And I tend to give like a little bit of a buffer where it's sheet switched only because I don't know necessarily if it's sheet switched right here or if it had done the sheet switch maybe a tiny little bit above it. So I'll give it a little bit of a buffer, but maybe something like that, you know, and then I'd erase this and probably call that good.
Okay. All
And then you can,
the other progress files from the trace you ran, are they kind of be deleted or are they relevant?
no, they're still there.
Yeah, but do you need them?
Oh, no, I delete them. So
Okay.
I keep the masks around that I make because I throw those in my regular paths directory and then those I'll continue to use. Like if I know these areas are right, I'll keep them around because, you know, I went through the trouble of making a mask, so I might as well keep it. But the other ones, I don't keep like all, you know, 10,000 files or whatever sitting around. I just delete them and then I'll start again.
Is that mask automatically saved at the right location or?
Yep, you just hit file, overwrite mask.tiff, and you're done.
Okay.
And then you can close this. Even you can just ignore that. I just hit Control D, and then you can go right back into like, all right, so I fixed that area. You know, say this was a really big one. You kind of have a couple ways of doing masking. You know, you could mask patches by masking your patches out before you run a trace, or you can run a trace, stop it when it errors, or you can run a trace for a long time and let it, even though you know it's erroring, you can kind of identify the areas where it is most likely to have problems and then mask this way. There's a few ways to do it. I don't really know what's the best way. I do the last one where I'll do like a trace that's just kind of like feeling out the scroll to see like, hey, where are my problems likely to occur? And then I try to mask them all at once rather than masking a little bit at a time.
Okay.
It's still, you're still going to like have some level of like iterative, like I thought, you know, I masked over here and for whatever reason I'm still running into problems, but that's the way
This area looks kind of rotated or something. Is that still fine? Or you just zoomed in on the left? A bit to the left? Yeah, like this?
Oh, up here?
No, in the bottom, it looks distorted.
Yeah, it could be. It could be that, I mean, it could be a few things, really. So there's a few things that influence whether it ends up distorted or not. A sheet switch will, for sure. and also this kind of thing where there's no other connecting points will. And the reason for that is all of these points have to be, this point and this point on a 2D plane are next to each other. If they're not actually next to each other on a 3D plane, they'll pinch. And that's where you get that distortion. Similar.
Where do you leave it?
Would I leave it? Maybe. It depends. It depends how bad it is. So sometimes the distortion is both. Sometimes the distortion is just a meshing artifact, where like the mesh is kind of like pinched in on itself. You can leave that sometimes. Sometimes I erase it. I don't really know like what the best practice is with that, I guess. It doesn't seem to influence the next one, like if I keep some of those in, because the warping and that isn't always necessarily like this right here. This is correct. The problem is there's a really big Z flip, or there's a really big change in this one's like X position. So like this sheet curves like this, basically. I don't know if you can see my hand, but it curves a lot like that again in 3D, but obviously it doesn't curve like that in 2D because it's a flat plane. And so, how do you show a 3D curve on a 2D plane if it's not perfectly flattened? You get kind of this.
We have a lot of these in the scroll 5 title region in the segmentation, right? Like the vertical switches.
No, the title region doesn't have sheet switches,
but
really.
In one or two of the segmentations, we have a lot of vertical air gaps, like vertical lines that are like this, yeah.
Yeah, you have this. What this is from is, where is my params?
Because of the step size or something, right?
Step right here. Yep. So what this means is it steps 10 voxels at a time. Actually, a little more because it's the source step.
Have you tested if this improves?
Yep, I have, and it does. The issue is that it increases the tracing time quadratically. So even just going down from 10 to 8 is a 16 times increase in the amount of points that it has to process.
So you only use it if you really want to get a region clean.
Yeah, and it actually is faster than you think. Like, the tracer is really fast, so even a quadratic increase in processing time isn't that big of a deal. At the end of the day, I just like, a lot of the time when I sit down to trace, like, I'm kind of impatient and I want the result. And so, like, I want to see it.
Usually, how long do you run your first trace? Like, okay, you have all your patches that from expanding. How long do you run the first trace until you like stop it and then you fix it and then mask it?
What I'll do is I'll take, so this global steps per window is the amount of optimization steps it takes. This is the part that takes the longest out of anything. So when I do my first trace, I'll probably drop this down to 1 or even 0, which will be a purely greedy trace. It won't do any windowed optimization. And then I'll make sure that this is 10, maybe 12. I'll crank my step size up a little bit, and then I'll run it for, I don't know, either until it stops, or maybe say it looks like it's never going to stop, maybe like an hour. An hour would be huge, like an hour-long trace.
Oh, so not even overnight or something?
No. At a global steps window of 1 and a step size of 12, like on scroll 5, you would end up with a segment almost probably, I don't know, half as big as that like 8115 segment. Like probably 1,500 centimeters or more. At least on scroll 5. It's different on scroll to scroll.
That's kind of a lot.
It's huge.
How far? Like, how do you proceed with increasing the global steps per window? Like, when do you increase?
Oh yeah, when do I? Yeah, so I increase once I feel like when I'm running it on a lower one, and I feel like it's not making a lot of mistakes. It's ran for a little while. What I'll do at that point then typically is like, I'll stop it, right? Like if I think that I've got most of the stuff masked, and I think that I don't, I think that if I'm like going to run it now, it probably isn't going to make a mistake for a long time. Then I'll increase the global steps window, only because at that point then I figure I don't really want to commit time to running a crappy trace if it could turn out to be a good one. So I'll step it up a little bit, and then that'll take some amount of time. it's kind of a feel thing, you know, at the end of the day. Like there isn't really like a perfect heuristic for it. It's just like, I think I've got most of my issues masked out. I started a trace, you know, with a low one, and it looks like it's going pretty good. Maybe I'll commit now to a bigger one, a more frequent step size. Or maybe even lower your step, you know, say you've got your step at 10 for most of them, and you go, okay, this looks pretty good, but in my maybe really tight regions, the step size of 10 is too high, and you know, if you take a step size of 10 over a circle, you're not really tracing a circle, you're tracing like a pentagon, you know, or an octagon. And that's what you're seeing in the center of scroll 5, because you can't really trace a circle that only has a radius of 100 voxels with a step size of 20.
Yeah.
So, you know, then if I feel like I've made most of my improvements, I'll lower my step a little bit. Again, you're committing to a longer processing time.
But the whole thing, if you restart, will be applied or like start from scratch, right?
Yes.
So if I lower the step size or the step and the global steps per window, it's very important to where I start, right?
Yes. Yeah.
If I only want to see like a small region, but I want to get it good, because running this on a full auto segmentation would take, I guess, long.
A while, yeah. I mean, on like a step size of 6 with 3 steps per window for like the full scroll 5 or the, you know, 60% of scroll 5 or whatever is probably overnight. Maybe not quite overnight, but, you know, at least 4 to 5 hours. So yeah, it's important you pick a patch near where you want if you're just trying to get a small area. Because yeah, you're right, you have to rerun it from scratch every time. There's no way to like be like, hey, start from here and then grow outwards.
So you can't improve. You can't really improve a finished auto segmentation except for like, yeah.
Right. Yeah. You just keep masking. But what you can do though is like if you make a couple auto segmentations, you can fuse them together, and then use that. Like combined, you know, say you've got 4 of them that are like they all don't have like huge sheet switches, or maybe say one sheet switches in some area and one doesn't. You can take an auto segmentation and mask out all of the errors in one, all of the errors in another, and then merge the outputs of those two together.
Oh, okay.
And that's the like fusion and infill. If you want, so the scroll price tutorial that I wrote, doesn't copy every single thing from this repository just because it's very verbose, but it's very helpful. So there's a number of things in here that you might find useful. This is the repository that Hendrik made for our submission. And if you scroll down through here, he goes through most of what I've put in the tutorial, but in some cases he goes into a little bit more detail. And then towards the bottom, he goes into more detail about like the actual algorithms behind them, and then some of the other parameters for them. So I would say like between this and I'm gonna update the tutorial to have more of this information, but until I do, you know, between this one and then the repository here, would both probably be your like best resources, along with obviously the channel that we just made, which you can always ask whatever you want.
Okay.
It's a lot, man. I mean, it's like it's a ton of stuff.
My attempt will be to create my own auto segmentation, like a full one. If I get this done, I'm happy.
You will. I trust me, you will. Like it's a lot at first. It's extremely overwhelming at first, but it starts to kind of come together quicker than you think. And then go ahead.
What I didn't understand so far, like really. The surface predictions, the algorithm from wildcards, it uses them, right? So I don't just do overlay and clicking my points, right?
Sorry, say that again?
I don't need it only for the overlay to click on it, to click my points for the seeding. The algorithm really needs it.
Yes, it actually runs on the distance transform of the surface predictions. So it doesn't even use the surface predictions themselves. It computes at each chunk a distance transform of that, and then what it's doing is optimizing it to the maximum, more or less, of that distance transform. So it's trying to take a point and move it as close as it can to that surface. That's why it's also slow when you start, because it has to compute the distance transform at every single chunk. But it caches it and it goes fast eventually.
Okay. So if I want to make the auto segmentation with the other resolution, you said you have already 2 surface stars, right? The regular and the eroded one.
Yep, and these are. I'll link them right here. These are.
Yeah, I have them. But it's just like.
Okay.
Are they a good point to use, or should I create a new one with the newest model, or
I mean, if you're just trying to figure out quick if it is the high res or not, I would probably just use those, because they're going to be good enough for that. Really, all you've got to do is like make a segmentation that's greater than like 50 centimeters, which should be easy even on those older ones, and then just match up the 2 spots. Scroll 4 in particular has enough landmarks on it that you should be able to find the same spot on the surfaces pretty quickly.
Okay.
If you wanted to use the models, though, you certainly can, and it's actually quite a bit easier now if you have.
It's an unit model, right?
It is.
That you trained?
So, yep. So I've got a guide for running that one way here in representation, which will walk you through how to install an NUnet, and then the commands for both training or inference on NUnet models on single or multi-GPU. And then the only issue with these is NUnet doesn't take ZARs natively. And so if you do this with...
Oh, so I need the TIFFs for the volume.
No, you need blocks of TIFFs. You need 3D blocks. I've got a script in here to do that, to turn a ZAR.
So I first need TIFFs to create blocks so that I can infer on them?
You need the ZAR to create
ZAR,
blocks.
okay.
Yep. So you've got this option, or if you have a ton of disk space, but you're going to need quite a bit of it.
I just bought a 4 terabyte, an additional.
So you might be good then. In Vesuvius now, in Vesuvius Python, if you just clone Villa, I have a ZAR-based NNUnet thing, inference thing, which works quite well. But again, it stores, so the way it does this is it takes your ZAR. Here's the other problem with NNUnet, I guess. I got to back up a little bit. NNUnet only does sequential inference. So even if you have an 80 gigabytes of VRAM, if you put a 256 patch in, it just does them one at a time. And the reason for that is that doing like a Gaussian blending stage in 3D is a giant pain in the ass, because you have overlapping chunks, and you've got to find out how to avoid race conditions there, and how to avoid locks or synchronization. And so they don't have any of that in there right now, but I wrote one for that. And the reason you need a lot of space is that it writes out the logits in float 16 in it just stacks them in not overlapping chunks out. It goes through 3 stages. And so you've got to be able to store all of scroll 4 in float 16. You need enough space for that. If you can do that, then you can use this, which is really fast. And this is just in Vesuvius. I could just run Vesuvius dot, literally you could just use this command. Let me just type it out quick.
I guess, and then I have the surface predictions SAR, but I need a OMIS SAR, right?
Yeah, you can. I'll send you a link for a script to do that too. That's really fast.
It's like
That's
a
also
gigantic pipeline. Okay.
Trust me, it is. It's ridiculous. Let me just finish typing this command quick.
You almost always need all the file types, like TIFF, SAR, OMIS SAR.
I know. That's why I wrote this, because literally every time we get a volume, we get it as TIFFs, and then you have to, turn it into 1,000 other things, and then it's a huge pain. I don't need that. I can just do path to input. Output. 1 second. I'm just going to give you the full command quick.
I guess it's called multi-ensemble because you're assembling multiple models, right?
Yep.
For the surface. Okay.
Yep. Yeah.
Was that better than just one, or?
Mm-hmm. It is. It's quite a bit better. Even 2 models trained on the same data with all of the same architecture and everything end up being better or worse in some places.
Mm.
But especially ones trained with different ones. Like there's ones that are better and some are better in compression, some are not. And so merging them together typically ends up better. I don't make ensembles for all of them. Most of the time when I make an ensemble, it's just because I ended up having a couple models laying around and I'm like, well, let's see what happens. So that would be like the command if you want to do the Vesuvius Python one. That's for predict. Then you would have to do blend logits and finalize outputs. Or you could just do Vesuvius dot inference pipeline. Also, the model is hosted on Hugging Face, so you don't even have to have the model installed or anything. It'll just rip it right off Hugging Face.
What do you mean Vesuvius inference pipeline? I just run it like this and then?
That's it.
Okay, but
you have to install the Vesuvius Python package first, though. So you would just have to...
yeah, the Villa repository, right?
Yeah, just clone Villa, cd into Vesuvius, and then just pip install -e and a period. So
okay, but I have to specify the scroll and everything, like, okay. Mm-hmm.
Yeah, so for your scroll, your input, you would do your whatever your ZAR is, your output, you would do whatever your ZAR is.
Okay, and one more thing, or question. For the scroll 4, for the other volume, right, there's only I think the ZAR that is uploaded, the volume, it's 16-bit or something?
Yes.
I think it's the 658 in the volumes. So I also need to transform this first to uint8. I have to mask it and I have to transform it to omizar, right?
This one is already omizar. It just depends. Is this the? Is this?
How do I know it's omizar?
Because it has 5 levels.
Okay.
The question is rather, is this the standardized one or not? Not.
What means standardized? Standardized in terms of?
Some of the ZARs are like.
From min to max value, like.
Yeah, there's a couple things that were done to them. So at one point, some people on the team wanted to see like if we could, like, make them smaller by. Doing basically.
Yeah, for some scrolls it worked and for some it didn't, right?
It worked okay. The problem is it looks different, and it looks quite different to the model. I'm gonna figure out what it is right now.
I think scroll 4 in general is not standardized yet and available yet in general. Maybe only the one volume that you had, that's in your folder, you know?
Yeah, it might be. I'm gonna find out if this is right now. Oh.
Okay, so I even have to do one more step. Standardize.
Well, maybe now. We don't know for sure. I don't know if this is standardized or not. Also, you wouldn't have to mask. What is going on here?
Okay. Yeah, but I'm thinking about pulling it up correctly, like from ground up, you know, for the volume, so that I have a good fixed ZAR.
Strange. Yeah. Yeah. Let me just. Why can't I get that? Oh, I'm doing it wrong. I'm going to find out right now if it's standardized, because that'll maybe save you some time.
Where does the transforming to uint8 happen? Is there a special script, or does it happen if I like transform from ZAR to omizar?
Yeah, I'll give you a script in just a second that will that you can do that right in it. I just want to figure out if this is the standardized one or not first, and because if it is, we'll have to go through a kind of a different step here. Fucking Python on the terminal. There. All right, let's find out. Desktop. Okay, you don't want this one. You don't want that one, I don't think. let's see if the different slice is any better. Not really.
Wait, what is it? Is that the?
It's scroll 4.
Is that this volume?
Yeah, it's just not. For some reason, it's not writing correctly. Let me see if I can. What are my? Not list. Conda list. Is it list env? I can't remember if it's conda env list or conda list env.
Yeah, same.
Let's find out. Conda info. We can just see if it. And then that was this is our here. Oh, we need that too. And I don't remember what that. It's export xcb something glx. Set glx.
Wait, so I guess you have a script for ZAR to grid and grid to ZAR, or?
Yep.
Okay, because I only see the grids to ZAR in the tutorial, but I guess must be somewhere.
It should be both there. Let's see, hold on.
For the inference, like only. Download this. No, it just says download the scroll 4 grids and not this.
Yeah,
like,
let me get you the other one second.
I'm asking you way too much.
No, that's okay. I'm happy to give this because a lot of this is like I want to show people. There hasn't been a ton of people who have done a lot of these other things, and so I haven't had to like make them as easily usable. But I'm more than happy to show people how to use them. I mean,
I would like to get it done, and then like after like I've done it, replicate it, and like write a tutorial. Okay, what are the pitfalls and what are the exact steps you have to do if you've never done it?
Mm-hmm. Yeah, that'd be great.
Like a flow chart, and okay, this, starting from the raw tiffs, you go there and there and there.
This.
Maybe that might be helpful for anyone else.
Yeah, no, I mean it definitely would be. Oh, bytes. 1 second. So this one will take your. That script will take you from TIFFs to your OMIZAR, and if you specify obytes 1, it will also do the 16 to 8 conversion for you. Oops, no, I didn't copy it. Sorry.
But don't I need first a script that does ZAR to grids?
Yeah, so if you want to go grids to ZAR, you do this other one so I just sent you the committee uploads.
I think the better direction would be first creating a good uint8 ZAR volume, using this for the surface predictions then, ZAR to grid. right?
Yes, yeah, that's probably how I would go. So I would go first. Let me just delete the first one. So first, if you want to do the full pipeline, you would take the TIFFs first, and you would run this scroll to OME, and you would just set your O bytes as 1, and that would take your TIFFs and turn them into an OME ZAR and uint8. From there, now, if you want to do the NN unit inference in the old way or the new way, if you want to do the old way, that not inferring on the ZAR, not from like the Vesuvius
Now,
one,
let's say the new way.
from there, you're good. Then you just have to run the Vesuvius.inference pipeline.
But I need the grids, right?
No.
No? It runs
No.
on OMSR?
From that, all you need is an OME ZAR. Yep.
Oh, okay.
If
So I can skip.
Yeah, if you don't have enough memory or enough storage to run that, then you would have to do.
I will have 4 terabyte. That should be enough.
Should.
At least.
Yeah, you could mess around with maybe changing the intermediate array like D type if you wanted to see if you were able to. I'm just gonna put this in here for completeness sake. If you want to run without Vesuvius Python inference modules with regular and UNet v2, you need grids from the ZAR, which you can get here. You can't use the grids from Spalufo on their own. So like even if there's grids in like a full scrolls thing, they have no overlap, and so you'll end up with really bad edge artifacts. So that's why I have this grids from ZAR, which is why you have to do this stupid OME ZAR first, and then that is because you need to get a grid that's actually overlapping the grid next to it.
Wait, okay. Because what is already given theoretically for that volume is a ZAR, right? But it's no, it is even an OMSR. Well, but I don't know if it's standardized, right?
It doesn't look like it is, but I would try to open that OME ZAR and see if it looked like when I was writing some of the blocks, it looked like it was missing some chunks, so that there might be something wrong with it. So I would open it in Cartez or something, and see if that's the case.
I would recombine the resultant predictions. So the surface prediction returns grids?
If you don't use the Vesuvius Python package, yes.
Why wouldn't I use it now?
I'm just saying if you can't. I'm just giving you this for completeness sake. So say
Okay.
in a couple
But
days.
if I use it, I would be fine, and like I save a lot of steps or like.
Yeah, you'd save a time.
Headache.
Yeah, absolutely. It's not really headache. It's just like moving shit around. It's just
Yeah. Okay. With scripts.
Yeah. And then here's a good script also to just have on hand. If you have a ZAR that is not a ZAR, that script will take a regular ZAR and turn it into an OME ZAR, and you can also specify bytes 1, and it will turn a 16-bit into a 8-bit.
Oh,
Or
okay.
even if you have an OME ZAR already, and you just want your OME ZAR to become an 8-bit one, you can also use that.
Oh, okay. So I could do the transforming to uint8 later. Okay. Mm-hmm.
Yep, and you could do that like with those surface predictions I gave you that are just they're not an OME ZAR right now, like those older ones. You could just run this ZAR to OME on those, and then you've got an OME ZAR with those. You don't have to like kind of screw around with doing TIFFs, then ZAR, then TIFFs.
Yeah, but I think I will do it from ground up and really standardize it, mask it.
Yeah.
Everything that's required to cut it down.
If you want to mask it, I have a model that masks.
Yeah, I know that there's the from James. I think James Derby was it maybe the masking.
I trained
but it. Yeah, it used the mask 3D or something. What was it?
Segment anything.
Or segment anything, yeah. But it's kind of pain in the ass to install this and get it running.
I have one that uses NN UNet.
Is it also did you also put it on Hugging Face?
I did not yet. This one also runs on if I don't, I've just got to put it on here quick before I finish that
Oh.
thought, or I'll forget. let me just copy it into there real quick.
Yeah, no problem.
I think it was this one. Yeah, OA2. This one operates on 2D TIFFs.
Okay, so I have to standardize to mask on the 2D TIFFs first.
Yes, if you wanted to mask one that is not masked, you would run it on the 2D TIFFs. And this runs pretty quick. It runs like it does inference on a whole slice. It runs also, actually, yeah, here's another fun part. I don't know how to make this short for you. This runs on 2D downsample. This runs on the second downsample, so 4 times downsampled version of the TIFFs.
But why would I, like, I need the original version, don't I need? Oh, it's just for the mask, okay, and then I can apply the mask?
Then you can upsample the mask.
Oh, what the fuck, okay.
Yeah, it's...
Okay, so this simplifies or like makes the masking faster.
That's the reason for it, is it runs a mask on a whole slice in like 2 seconds.
How can I downsample the 2D TIFF files easily?
You could use...
Is there a script that, so...
Yeah, I have a script that goes... You're going to like this. I have a script that takes an OMEZAR, and then what I do is I take the OMEZAR, I wrote this initial masking for like ones that were existing because it was just like a test, like, I don't know, a couple weeks ago that I made it. And I just took so you have 0, 1, 2 in your OMEZAR. Well, 2 is the 4 times downsampled. And so I just sliced that. I just did, 4 ion range of the Z, shape and the first index of the shape, which is the Z. So I just iterated over the Z levels and just wrote the slices out. And then you run the model.
But I guess I want to start on TIFF files and not on OMEZAR.
Yeah, and so for that, I mean, I can explain how to do it, but I don't have a script for it yet.
Okay, but no, that shouldn't be the problem. Like you're just like you're taking 1/4 of the version of the resolution of the original TIFFs, right?
Yes.
1/4.
So yeah, you could just do like SciPy zoom or something, and then you end up with that, right? So that will give you your XY dimensions will be the same, but the problem is when you downsample it twice, your mask is actually for 4 of the full resolution slices, and so you have to do like np.repeat or something.
I have to upsample the mask again, right?
Yeah, and Z is the hardest part, but it's still pretty easy. You've just got to basically assume that each single mask slice is 4 full res slices.
Okay.
It's not that complicated. It's just a long, irritating at times pipeline to go from one to the other.
Okay.
So yeah, once you have that, I mean, once you've got your full res mask slices, then you're good. Then you can just do scroll to OME.
Where do I do the standardizing?
I wouldn't do
On what?
standardizing.
You wouldn't do it?
Nope.
Doesn't it save memory or something? Or like for completeness?
No, because we're not really standardizing that way. They did it a little bit, but like it's not. We're gonna standardize in a different way going forward on like the scan level, like before we put them out. And I don't think that standardization, like in terms of like dropping the last 8 bits or something like that, or 4 bits, like you end up with volumes that look different than other volumes, and I don't really know that there's a benefit in that.
Is there a way to instantly transform 2D TIFF stack to OMEZAR and UNT8, or do I need the intermediate star?
Yeah, you can do it right away. So that scroll to OME that I sent,
from Countess?
Scroll to ZAR rather. Scroll to OME.pi. Yep. If you just specify obytes 1, it will take 16-bit TIFFs and write them out as UNT8 OMEZAR.
All right. OMEZAR, right?
Yep.
Okay. Holy shit.
It's a lot.
Yeah, okay, but actually it's 2 steps now or 3.
Yeah, it's not. If you
Yeah,
can if you can take the masking, like if you figure that part out, and it's not that complicated. It's just a little bit of troubleshooting, like in terms of like downsampling and then re-upsampling. Once you figure that
but
part out, it's really
for
just 2 steps.
convenience, having all these steps documented in like a workflow, and that would be good. I think also for future volumes. I don't know if you plan on publishing these, like in what way you publish them,
I don't know. Yeah, I mean, a lot of these things like I came up with like over the years.
Yeah. Because I guess for the scroll 5, 3, 4, it was all like raw data, right?
Mm-hmm.
Or like the raw volumes.
So for our future volumes, though, like we are planning on releasing them fully masked in uint8, already done.
Okay, so basically this pipeline.
Yeah, because we don't want you guys to have to do it. Like, it sucks for you to have to do that.
Yeah.
Right? Like, we want to make the data available in a format that's good right away,
but
rather than.
Did you do all the new scans, only in 1 resolution or 2, or what is the?
We did a number of different resolutions.
Okay, because I don't think it's yet clear what resolution gives the best ink detection.
It's not, and we're going to have a very fun set of data to play with. We did a whole pile of experiments on a 1900 slice slab of a specific scroll, and at like a bunch of different energies, a bunch of different resolutions, all in the same spot.
Okay,
and
that's great.
Yeah, so we'll be able to compare a ton of that stuff. We're still working on getting everything reconstructed. Like, you wouldn't believe how long it takes to do all this stuff, just to go from
like the pure processing, or?
Yeah, it's really, honestly, it's just like the manual steps.
Okay. Like what I have to figure out right now with the volume, you have 10 manual steps for the processing there.
Yeah, before we even get to that, there's another 10 things you've got to do. So, and then also the raw volume of data, like the amount of data you're moving around. The scans come out in float 32. So you have.
Oh, holy shit.
Yeah, so you've got 100 terabytes of data. Like each scroll is like 25 terabytes that you've got to then.
What
get.
The hell?
It's.
How do you even, like, the largest SSD I bought was like 4 terabytes. So.
Yeah, AWS is the only way, really. I mean, it's a process, man. It's a huge process, and so it's like. It sucks, like before I joined the team, it's like, the team goes and does scans, and you're like, well, where the hell are the scrolls, and I always felt like that. And
where the hell are the scrolls?
Yeah, and now I'm on the team, and I'm like, damn, all right, I get it. Like, holy crap, there's just so much to do before you end up with an actual, like, good volume to then release to people. So we're working on it. I promise you that. It just takes forever, and we're not, there's not a ton of people, so just takes time. And data transfer too. I mean, think about, like, if you want to transfer like 100 terabytes from England to the US over the internet, it's just all of this like crap that takes forever, but it's fun. I mean, it wouldn't be fun if it were easy, right? I mean, maybe it would be, but that's what I tell myself, at least.
Okay, I'm gonna see if I get it. I will get some first patches on that other volume, and even if it's like the same volume, I don't know yet. If you messed up, or
there's a good chance I messed up, dude. But I believe you that you looked at it, right? So, like, I'm not saying that you're incorrect in what you're saying, not by any stretch of the imagination, because just as easily as I could have messed up the naming in the metadata.json, I could have accidentally grabbed the wrong volume.
Yeah, the thing is, it just felt like a different resolution than everything I've worked before yet. Scroll 1 was the same resolution, like the one I'm going to make now. Scroll 5 was the same resolution, like the 7.91 micrometers. that was the resolution where I labeled the whole time so far, and yeah, this auto segmentation is like totally different, and you don't know what you can trust and whatnot, and I compared it to the hand segmentation, you know.
Yep.
The hand segmentations that I think David and Harry did.
Yep.
And these are, I don't know, these are different. Better in some sense.
Yeah, I mean they definitely look different in one way or another. So yeah, I mean,
I don't think it's only from because it's hand segmented and it's like the sheets are better followed. I think it's the scan resolution. If you look at both and compare them, it's really, you can see it.
Yeah, I
but
mean
it doesn't make sense because the one you did is better resolution.
Yeah, this one 2040. I mean, it definitely looks different. You know, like
it looks different if you go really into detail into like finding signal. Then you start like, okay, I don't know, that looks totally different. And in the hand segment thing, it doesn't look that different.
I've always thought this was a letter.
Yeah, you never know until you know.
I know. That's, dude, going from, oh, I think that's a letter to it's a letter is like the largest leap of all time. It's brutal. It's absolutely brutal. Like, there's so much stuff on these scrolls that I am so certain is ink, but like it's just part of it. You know, like I can't put a whole letter together.
Yeah, and you also don't know how large is the line. How large is the letter? Where does the line start? Where does it end? That's you think you're seeing letters, but actually you labeled like 2 or 3 lines.
Yeah, it's brutal. It's so brutal. I've looked at this scroll at scroll 4 for so long that like I could just get dropped in on like any of these segments and figure out where I am. I had to stop looking at this scroll because at, like last year in March or something like that, like I looked at it for like hundreds of hours and I was just like seeing letters everywhere. I was like, I gotta get the hell out of here. Like I can't.
But nothing worked out, or?
No, I just couldn't figure it out, man. I didn't do. There's a lot of things that I think I could have spent my time better on now. I on Friday I'll go over like I made a trainer in Napari. I haven't like published it in the community yet, just because I've got a little bit of polish yet on it, but that you can run. It's just like Vesuvius. It's in Vesuvius Python right now, but it's just called Napari trainer. But basically, you open it up, throw a couple layers of data in there, and you just draw on it and hit train, and it'll train a model right in Napari on your
like ink detection.
Yeah, whatever kind of. Right now, the model uses
like a 3D. Okay.
Yeah, 3D or 2D. It uses the same blocks that NNUnet uses, so their dynamic network architecture is the package that they use. It's made by them, but it's just residual encoder or UNets.
But have you tested it so far on like Scroll 1 or something? On a region that you know?
It works.
Really?
Yeah.
Is it the letters that you recently posted in general with the crackles, like?
Those are different. Those ones I made. Those ones I just made with Crackle Viewer, and that's a different model. This one, like the point of this one that I wanted was like, you know, say you're in a scroll and you're looking at this image, right? And you don't really know what's ink, you don't really know what's not. You don't really want to go and label like everything. You just want a really fast way to say like, I think this texture is ink. You can just mark it a few spots, hit train, hit inference, and it'll run inference on the whole layer you currently have open in Napari and just show you right away, hey, does that texture actually correlate with anything or not, you know?
Yeah, okay, so basically if there's similar pattern somewhere.
Right, yeah, because that's what I wanted was like a way to like really quickly like test out what
in 3D?
Yeah, it does 3D or 2D.
Damn, okay.
So yeah, I'll have it. I'm gonna show it enough Stars on Friday, and it should be in a pretty good state by then. It's in a decent spot right now. I mean, if you download the Vesuvius package and just install it, it's just Vesuvius.Napari trainer. But I don't have any guarantees for it till Friday. But if you wanted to play around with it,
nah, no problem. I'm messing around with Scroll 4.
Hey, perfect.
Well, by the way, is there a reason why you haven't done patches for Scroll 2? Is it because I think Well, a time ago, I looked into it and it looked like a mess, but
It's
I can't remember.
it's a mess. It's really bad. Like,
But isn't it even possible to create some patches in some regions or
oh
some
yeah, no, it
larger?
is absolutely. There's no reason I haven't done it in Scroll 2. You wouldn't get a lot of them, but you would get some. Absolutely. The other problem is that the Scroll 2 volume is like the reconstruction is broken. So there's like a giant like Death Star in the center of it.
Oh, okay.
Like there was an issue where like they literally like lost. There was an issue at the scanner when they were doing it, and so they like don't have some parts of the scroll of the actual scan.
Wait, so you
And
actually would need to rescan it?
it would need to be rescanned for it to be fixed. Yeah.
Okay.
Yeah. So what happens is like when you're missing grids, when you do filter back projection, you get these like crazy artifacts. Like it looks like the Eye of Sauron in the middle of that scroll or something. Like it looks insane. And that artifact like messes up so much of that scan that like I have avoided it just because like that scan is in such bad shape that like the effort hasn't to me really seemed like worth what I might get out of it. Not to say that we shouldn't do it. We've always had so many other things to do that it's just always gotten kind of pushed down, you know?
I see. Yeah.
But I mean, if someone ran surface predictions on it, you know, even on a part of it, it would be interesting to look at. I think Scroll 2, I've done some manual segmentations in Scroll 2, and I'm pretty convinced that there's ink in there of, similar type to like Scroll 1, but again, it's hard to get good manual segmentations of like a decent enough size. Like not only do you need like part of a letter, you also need a big enough size to say like this is for sure or not ink. Like to say one letter is a letter, you also need like a couple around it.
That's also the problem. Like with training a model that predicts enough letters in a region, you need enough other ink so that you don't have to train on that region where you want to predict, you know?
Yeah, I mean that's the thing, right? You know, there's tons. I mean, there's a million times I've looked at patches or stuff where I'm like, you know, this. Even if I saw like an alpha right here and it was like damn near perfect, if there was nothing around it, I can't say for sure if it's ink or not. Like, you know, you need like 3 or 4 letters or like 2 letters in like a clear column or row delineation. Like you need so much to say whether something's letters or not. It's such a pain for that, but I really like ink detection though. I just haven't had time to do too much with it yet, but I'm hoping this year yet to get back into ink detection quite a bit. So we'll see how that goes, but I'm going to take off. As always, my office hours ran like 2 hours long, which they always do, which is fine. I like I always schedule for them for like an hour, but I'm like, there's no way in hell I'm gonna stop talking scrolls in 1 hour. It just ain't gonna happen. So
yeah, but it's really helpful.
No, that's why I like having them. You know, I wasn't like the only reason I didn't have them for a couple weeks is we just had a ton going on. Like I just literally did not have time. But I'm trying to make it a point to have them again because I really enjoy them and it's a really good opportunity like all the questions you asked today, like for example, like transferring all of that data to you through text is way harder than me just showing you, it's like
I would never have asked all these questions by text.
Right, this is just such a more efficient like method of just like transferring some of like the knowledge that I've gained or the stupid like processes that I've created to other people,
All right, then thank you.
Yep.
Thank you a lot. I'll try to get the volume and then tell you if I find something.
Cool. Sounds good. Maybe
or
we'll
like
see you
find
Friday.
it
Okay.
if it's the thing. Goodbye.
See ya.